So I had problem number 2 on page 18, and it says calculate the products A over C, B over D times 1 over 0, and A over C, B over D times 0 over 1, and interpret the results. So what I did is the row by columns. So row 1 was A and B times column 1, 1 over 0, and that's right there. And when you add those together, you get A, and then if you do row 2 times column 1, C times 1, C plus D times 0, you get C. And then if you try it with the other side, you get the exact opposite because the second matrices was switched. And so in that one you get B over D. And then with the lower ones here, down there, you get row 1, and you can add the second matrices, the 1 over 0 and the 0 over 1 together to make it a 2 by 2. And if you multiply the whole thing out, you just get A over C and B over D in one big 2 by 2 matrices. And I guess they're identity matrices is what Mr. Tating said.
So we did page 18, number 3. And so 2 industrious PEA students are trying to find the distance across the Squamsquat River after marking points A and B 60 meters apart, right there. On the bank, they cite the Powderhouse P on the opposite bank and measured angles PAB and PBA to be 54 and 114, right there. And this enables them to calculate the altitude from P to the baseline AB, and to the nearest meter, what was their result? So you find angle 12 up here from doing it subtracting 180. They do the law of sines, so sine 12 divided by 60, and then sine 54 divided by BP. So it's 60 sine 54 over sine 12, which you get 233.5 meters, which is BP right there. And you find that it's 66 degrees right here from 114 minus 180. And you just do trig. It's sine 66 equals x over 233.5, which ends up to be 213.3 meters. So.
If sine A is known to be 0.96, then what can be said about cosine A? What if it is also known that A is an obtuse angle? So to find the angle that is made by sine A equaling 0.96, I just did inverse sine right there and got 73.74. And then I plugged that into a triangle like it was a unit circle. And I did cosine 73.74 equals x over 1, and I got 0.28 for that side. And then it says, what if it is also known that A is an obtuse angle? And so I just draw the same unit or same triangle, reference triangle on that side, and so you just change the sign.
So on number 19, or page 18, number 5, basically it asks you find the components for the vector projection of 12, 5 onto negative 9, 12. And in order to get the vector projection, you have to use this equation. Basically, when you do that, you have to take u and multiply it into v to get that, of course. So we did that right there, and we got negative 48 out of doing negative 108 plus 60. And we put that, and we substituted the u times v for the negative 48, and we took the 15 and squared it, and we took the vector negative 9, 12 and multiplied that by that, and we took turns with the negative 9. We took negative 48 divided by 225, and we multiplied it with negative 9 and 12 to get 1.42 and 2.56. And negative 2.56.
So, page 18, number 7 says that 2 fire wardens are stationed at locations P and Q, which are 45 kilometers apart. Each warden sights the forest fire at F. Given that angle FPQ is 52 degrees and angle FQP is 43 degrees, find the distance from F to the nearer warden to the nearest 0.1 kilometer. So for this problem, you're going to need to use the law of sines. So you would do 45 divided by the sine of 85, and then you'd use a proportion to make be x over the sine of 45, because you're trying to find what that side would be. And so when you multiply that out, it would be x sine of 85 equals 30.69. So then after you divide 30.69 by the sine of 85, you would get x equals 30.81 meters.
Okay, so this is page 19, number 1. Jamie is at the point J equals 0.8 offshore, needing to reach the destination D 12-3 on land as quickly as possible. The lake shore is on the x-axis. Jamie is in a boat that moves at 10 units per hour with a motorbike on board that will move 20 units per hour once the boat reaches land. Your job is to find the landing point P equals x0 that minimizes the total traveling time from J to D. Assume that the trip from P to D is along a straight line. Okay, before I start, I'm going to say that when I copied my work down neatly, I accidentally messed up and wrote 0 right there. And right there, those two numbers should be reversed. Anyway, I began by making a chart over here, experimenting with different locations of the point P. So first I placed it at 0, 0, and I found the distance between the point J and the origin to be 8, obviously, and I divided it by the speed to equal a time of 0.8 hours. And then to find the speed on the motorbike, I used the Pythagorean theorem. So I did 3 squared, as you can see over here. 3 squared plus 12 squared divided by and then the square root of that divided by 20 units per hour to find the time on the motorbike, to find the total time. And repeating that with P equals 2, 0, not 0, 2, I found the time again using Pythagorean theorem, and I realized that the x value for P for this formula, if you replace the 2 with x, you can find that's the length of the third side of the triangle. So I got this formula right here for that. And then down here I realized that for the Pythagorean theorem, 3 squared remains constant, but the second side of the triangle would be 12 minus whatever the x value of P would be. So I got this formula right here. And once I FOILed out the terms and simplified it to get an equation for T, the total time it would take, and I graphed this equation, and it looked a lot like this. And then on my graph, I found the minimum value, which was 4.22, 1.32. And the value 4.22 is the x value that it would be at the minimum. So this would be reversed, 4.220. And it took 1.32 hours, which would be the t value.
Okay, basically in this problem, you have your cosine x graph right here, and you have your dotted line at y equals 0.74. Now the whole idea here is that this point right there is at 42, comma 0.7431. And we want to find where these other points are, R, S, and P. Well, think about it in terms of the unit circle. So this unit circle goes around, starts at 0, right, which is right here. And as it goes around, it hits that 42 degrees. Cosine 42 is 0.7431. So if we keep on going around the unit circle and think about cosine here, cosine hits right here, -1. At here, cosine is 0. That's this point right here. Over here, cosine of 180 is -1. Here, cosine 270 is 0 again, right? And then here is r. So to figure out where r is, you just take 360 minus 42, and that got you 318. Okay? So then to find this s, these are pretty close together because I'm just going from here to here along the unit circle, from r to s. So now I just take 360 plus 42 again to get 402. Now remember that cosine is positive in just these two quadrants right here, quadrant 1 and 4. So that's why it takes so long to go from quadrant 1 to 4, but then from 4 to 1 is pretty short. So P, what would that be? If we're going backwards, -42. So there's your points P, R, and S.